Hey future chip designers! Welcome back to Verilog from Basic to Advanced, powered by Protovenix. In the last video, we explored behavioral modeling, using initial, always, and procedural control. Today, we're diving into something that makes your Verilog code modular and reusable, tasks and functions. Think of them as the mini programs inside your HDL design. When your Verilog code starts growing, you don't want to repeat the same logic everywhere. Instead, you can group that logic into tasks or functions, just like subroutines in software. They help in code reuse, better readability, easier debugging. Now, both look similar, but they serve different purposes. A task can include timing controls, like delays or event waits. A function, on the other hand, executes in zero simulation time, no delays allowed. Tasks can have multiple outputs. Functions return exactly one value. Tasks are invoked using their name directly, task_name. Functions are used inside expressions, result equals func_name. Example, task display_values, $display, in task function, 3 o'clock, add equals x plus y, in function. To declare a task, we use task in task. For functions, we use function in function. Tasks are called like this, display_values. Functions are called within assignments, some equals add. Simple, right? It's all about whether you want timing and multiple outputs, or just a quick return value. By default, Verilog tasks and functions are static, meaning they share the same storage across calls. But when you declare them as automatic, each call creates a separate copy of variables. That's super useful for recursive calls or parallel executions. Example, task automatic compute, integer I equals I plus 1, in task. Now each call keeps its own I, avoiding conflicts. You'll often use tasks for test bench routines, generating clock, resetting signals, printing outputs. Functions for mathematical or combinational logic, like parity check or adder units. Together, they make your design modular, clean, and scalable. So let's recap. Tasks can include delays, multiple outputs. Functions, zero time, single return value. Automatic, independent storage for each call. In the next video, we'll explore timing controls and event simulation, where we control how signals change and interact in time. Stay tuned with Protovenix, making HDL learning visual, smart, and exciting. Dear Lightbulb.